All right, we are going to be finding the horizontal and vertical distances in example 3A. Okay, so the distance between 2 points, that's what we're going to be finding. So given that you have 2 points, so here's 2 points, xy and xy. Okay, please tell me what's the first point. Is it this one or is it this one? Or what's the second point? Is it this one or this one? We don't know because they both look exactly the same. That's why in mathematics what they do is they use little subscript, and the subscript tells you what is the first point and what is the second point. So they use these little identifiers, and subscript are these little numbers like this. So this is the first x point. This is the first point. So we're going to put an x1 and a y1 right there. And notice how it's really little and it's kind of smaller. So then this is the first point. Okay, then that means if this is the first point, this is the second point. So now we're going to put a little subscript 2 here and 2 here. This identifies that this is the second y, this is the first y, this is the second x, and this is the first x. So you can tell the difference between the 2 points. First point, second point. All right, let's talk about the horizontal distance. The horizontal distance is actually found by taking the difference of the x values between the 2 points. So how we say that is we take this line is the absolute value of the x2, so that's the x from the second point, and we're going to subtract that from the x value from the first point. And these big lines, that means that we're just going to take the absolute value of it. So we are taking the x value from the second point, this one right here, and we're subtracting that from the x part here. So we're just subtracting those two x values to find the horizontal distance, which has to deal with the x-axis, right? So the vertical distance has to deal with the y-axis. So we're going to be finding the difference of the y values, which is the absolute value of y2 minus y1. So now we're only looking at the y part of each point. So we're going to take the y2 here, which is found in the second point, and we're going to subtract it from the y1, which you find that right here in the first point. So those are the formulas that we're going to be using for finding the horizontal and vertical distance. So let's look at our first problem. We need to find the distance between K and L. If we look here, K and L, is that a horizontal or a vertical distance? This is a horizontal distance. So we are going to be using this formula right here. So first I'm just going to write down my points. My K is -2, -2. And then my L is 4, -2. I'm going to go ahead and label these points. This is going to be my first point. This is going to be my second point. So I'm going to call this x1, y1, and this is going to be my second point. So the x, this is going to be the second x, and this is going to be the, what is this, y2. Notice, since we're dealing with a horizontal, do we only pay attention to the x's or the y's? And you're right. With horizontal distance, all we care about is the x values. So we need to find what this x2 is, which is right here, okay? And we're going to subtract it from the x1, which is found right here. So since we're finding horizontal distance, we could care less about these y parts at this point. So then we're going to write our formula. Our formula is the absolute value of x2 minus x1. Okay, and the x2, that is the pink, and the x1 is the yellow. So we just go ahead and substitute those values in. I'm going to write the absolute value again. My x2 is just a +4, so I substitute that in. I just write that negative or minus sign there. And then my x1 is a -2, so I'm going to write in -2, and I'm going to take the absolute value of that. So what I see here is that there's a negative and a negative, a negative and a negative. Those are a positive. So we end up with the absolute value of 4 plus 2, which is 6. And that means if we take the absolute value of 6, that's just talking about the distance away from 0. And this is 6 units away from 0. So it is a positive 6. That is our distance. So we can say that line segment KL in geometry, we talk about it like this, equals 6. And that would be our final answer. Okay, let's go ahead and do another example right up here. Let's see here. Okay, for this one, we're going to find the distance between each pair of points. Now we're going to look at M and N. Now M is here and N is here. And what kind of distance is this? Is this a horizontal or a vertical? Yes, it is a vertical distance. So we are going to be paying attention to this formula right here. Now we only care about the y parts. So first I'm going to go ahead and write my ordered pairs. This is M, which is 2, 6. This is going to be my first point, and then my second point is going to be N, which is 2, negative 6. So whatever I'm doing now, this is what I want you doing on your homework assignments. So, and writing down in your notes. So this is our first point. We're gonna call this our X1 and our Y1. It's alphabetical and it's our first point. This is our second point. So we're gonna call it our X2 and our Y2. This is kind of like defining our variables, saying what's gonna be what. Okay, and then the vertical distance, that's what we're finding. It's a vertical distance, so we're gonna go ahead and write this equation down, and it is this, y2 minus y1, the absolute value of the difference between y2 and y1. So y2, we have to find where that is in our points, and y2 is right here. So we're going to be taking that negative 6 and substituting it in there. And then we have to find our y1, which is here. So we're going to substitute that 6 in there. So let's go ahead and do that. So I'm going to substitute absolute value. I'm just going to write that. This is a negative 6, so I'm just going to write negative 6 minus the y is a positive 6. And there we go. And this is going to be a negative 6 minus 6. They're both negative, so we just add them and keep the negative sign. So 6 plus 6 is 12. They're both negative, so it's going to be negative 12. And then the absolute value of negative 12, well, negative 12 units away from 0 is just 12 units, so the absolute value is a positive 12. So what that means is the distance from M to N equals 12. And there we go. So now it is time for you to check it out. I want you to go ahead and try both of these problems, 3A and 3B. Go ahead and pause whatever device you're using, and then come back. And there's our lovely friend, the pause dragon, reminding us to always pause, work it out, and then come back and we will check and see if you got it right or wrong. Okay, see you in a bit. Bye. All right, we are back, and we're going to find the distance between A and B. If you see, A and B is a horizontal distance. So, because it is a horizontal distance, we are going to be using our horizontal distance formula, which is this one right there. First, let's go ahead and write the points down. So we have A is negative 2, 4, and B is 6, 4. So this is going to be our X1, this is going to be our Y1, this is going to be our X2, this is going to be our Y2. We're going to go ahead and write that formula down. The formula for the horizontal distance is the absolute value of X2 minus X1. And notice the horizontal, it only is paying attention to the X values. So we are going to find that X2, which is right here, and we're going to subtract it from our X1, which is found right here. X1, X1. Okay, let's go ahead and substitute these values in. So that's going to be the absolute value of 6 minus x1 is a negative 2. Absolute value of that. Now a negative and negative is a positive, and basically we have 6 plus 2, which is 8. So we're taking the absolute value of 8, which is 8. So that means the distance from A to B equals 8 units. Now, we could check that. And the first thing we have to realize is about this graph is that each one of these little hash marks is a 2. So it's 2, 4, 6, 8. Now if we just count across and we start here at A and we go 2, 4, 6, 8, you can see that the distance of A and B is 8. So we did it correctly. But I want you to get in the habit of using a formula and substituting and defining your terms and all that stuff. So even though we can just count 2, 4, 6, 8, I want you to go ahead and show all your work here. Okay? On to the next one. Check it out, example 3b. It says find the distance between each pair of points, C and D. Okay, here is C. C, first we're going to write down our points. C is 4, negative 2, and D is 4, negative 8. Define our terms. This is our x1, this is our y1, this is our x2, this is our y2. We're going to write down the vertical distance formula, which was right there. So it is the absolute value of y2 minus y1. Okay? y2 is here, and that's right there. Negative 8. We're going to substitute that in. And our y1 is right here, and this is our, this is our y1. It's a negative 2. Okay. Let's go ahead and substitute those values in. So we're taking the absolute value of negative 8 minus, that just drops down, y1, which is a negative 2. Make sure whenever you plug a negative number in for a variable, you put it in parentheses. Okay, there we go. Here we go. 2 negatives. Those are going to equal a positive. And then we have a negative 8 and a positive 2, so the signs are different. We take the difference between the two, so the difference between 8 and 2 is 6. And 8 is bigger than 2, and 8 is a negative, so that means our 6 is also going to be negative. And then we just take the absolute value, which is 6. Absolute value of negative 6 is 6. And that is what our distance is of CD. Now let's go ahead and check it to see if we right. Let's go to the graph. Now notice these are the scale of these are 2, so it's each hash mark is 2, so it's 2, 4, 6, 8, right? So we're going to start here and we're going to go down. That's going to be 2, 4, 6, and yes, it has a vertical distance of 6. So if you got that right, great job. Yokorikimashita. You did a good job. We will see you next time. Bye.